Good morning, good afternoon, or good evening, depending on where you are. And welcome to the Broadcast Electronics Elenos Group webinar on the Avatar Direct Sampling Test Set. I'm Chuck Kelly, and I'm your host. And I'm very, very happy to have an old and dear friend. I don't mean that he's old, I mean that we've known each other for a long time. John Lackness. Welcome, John.
It goes both ways. That's right. And we go back a long way, Chuck.
About 25 years, I think.
At least I know the last time that I worked with the broadcast electronics and with the Marty division at that point. So even before then.
Yep. So, as usual, we've got an outline of things we're going to talk about today about this innovative and creative product. And it all starts with the $1,000,000 question. So, here's the toughie for you, John. Broadcast Electronics and the Elenos Group is known as high quality manufacturers for FM, AM, TV transmitters. This
Right.
isn't any of those. Why is this here?
Yeah, that's a very good question. That people are looking at this and saying, well, this isn't exactly what y'all have done in the past, and we have to give the props to the Elenos group, who's allowed us to spread our wings, so to speak, and venture out from the what we've done in the past with the AM and FM transmitters, our new line of TV transmitters, upgrades with Audio Vault, and this is a new venture into the test equipment world.
In a way,
Avatar is a wonder piece.
I think it reflects changes in the industry. I mean, since we've known each other,
Absolutely.
John, this industry has changed a lot. Used to be when I was chief engineer of stations, why there were several people as engineers in a single radio station, and there was a lot of test equipment. I remember being in a relatively small market station in Colorado, and
Hmm.
had a spectrum analyzer, and it was necessary to have that test equipment so that we could do performance tests on our equipment. And that's not the situation today. And today it's kind of reversed. You've got one engineer for a dozen stations, and there's no test equipment and no budget
Exactly.
for it. So this,
Exactly. And this is where this takes the place of that big spectrum analyzer.
yep. And even when back in the day when they had modulation monitors, those were single frequency devices.
Yep.
This device allows you to measure the entire band, all the stations on the FM band, and so that's pretty cool and exciting. So let's get to it. What is the Avatar, John?
Well, Avatar, as you can see, it's a small little device that you can carry with you anywhere. 4.5 wide, inch and a half tall, 3.5 deep. It's a 16-bit SDR. It's got specialized broadcast FM analysis tools, and it is absolutely perfect for off-air monitoring or direct connection by sample port on your RF line section. And the
Mhm.
recommended signal level up to 30 dBm. The
So it really
frequency,
goes down to about minus 60, right?
that's right. It goes down to about minus 60, so minus 60 up to about minus 30, perfect range. Frequency range of 100 kilohertz over to 140 megahertz, and we'll take a look at some of that here in just a little while. Um, this is used with a laptop or a tower. The operating minimum recommendations are Windows 10, 4 gig of RAM, 4-core CPU running 2.5 gigahertz, 10 gigs of hard drive, and a monitor screen capable of 1600 by 900, because there's a lot of stuff that you're going to be visually seeing, and we'll show that here in just a second.
Right now.
Exactly what we are doing. And this is what you will see at a glance. This is your second set of ears to help you assess the health of your audio signal. If you hear something going on on your station or one of the others that you take care of, you don't have to just drop everything. You can look up at a monitor. Say you have this up on a large monitor or just your computer screen in your office. You have everything right here in front of you. And we're going to break this down into thirds here. We're going to start at the top and then middle and the bottom and show exactly what is going on with your signal. And here we are. This is your RF waterfall and your RDS as we stop at the top third of the Avatar. At the very top, though, the very top line, we have a start and stop little buttons to start and stop your measurement. We can go up and down your frequency here, and you can adjust this yourself. You can pre-do this to where you can go up in a 1 meg or a 500 kilohertz uh, uh, each
Steps.
with each click. Yes, step. Thank you very much, Chuck. I was trying to remember what that was.
Mhm.
Next over, there's your volume control over here. You can raise and lower, or you can mute this. And then, of
Mhm.
course, over to your right is just what's showing up on your RDS.
Right.
Right below it is your RF. Well, actually, right here, here's your presets. We do have 10 presets that you can set up yourself, and you can just go through and click on everything that you have or other things in the market and be able to look and see what is going on and to get a visual representation of what is happening, not only in your station but others in the market.
Mhm.
Below, let's look at the big waterfall. We call this the waterfall. It's nice and pretty. We are looking here. We see the two HD sidebands either side of the horizontal axis here, with time being the vertical axis and the most current at the top, and then the signal level is brightness. I have a hard time with the word signal today for some reason.
Mhm.
To the right of this, here's all your RDS info. You have your frequency that you're showing at the top, your PI code right there. That's your program identifier. And the reason why I'm explaining this, and I know I have at least 1 or 2 people on here who are just getting used to RDS, and so I'm going to explain just a little bit about this. This isn't actually your call letters. This is a hexadecimal, a digital address that corresponds to the call letters. So it keeps a receiver from auto tuning to another station on the same frequency. If you want to have a little fun with this, you can go to an address called picodes.nrscstandards.org, and if you have a set of call letters or if you have a PI code, you can look this up, and it can be a rabbit hole real quick. You can go through and find stuff and sit there for an hour. Right below this the PS. The PS is your program service, and this is like a station moniker, say like 97.1 Eagle or News Talk Radio or whatever the case. You want to put this, will go right here under your PTY, or excuse me, your PS.
Right.
The PTY is your program type. You would select either news or rock, opera. There's a whole list of stuff that you could choose from. So if people have a receiver that they want to look for stuff specifically by a format, that's what it would key in on. Below this is in fact, we're going to go down below the PHY, which is this is your physical layer of the data channel, and
Right.
it's telling the receiver what data it's type of sending.
Yep.
Were you
So if you're trying to
Chuck?
diagnose the RDS on your station, something's not playing on certain receivers, you can actually see the digital data that the RDS is sending out here and help make the diagnosis of what's actually going on.
That's right. And
Mhm.
to the right, just a little bit up at the top, you see one that's called MS, and this basically just indicates either music or speech.
Yep.
Below that is a decoder information. This tells the receiver whether the audio is mono or stereo. Below that is TP and TA. The TP is traffic program, and that's used when stations broadcast traffic bulletins,
Right.
such as if you have a news talk station, then traffic announcement is like when the traffic bulletin or other
Sure.
important information is needed there. To the right of that, this is an RDS uh, uh,
Constellation view.
constellation. Thank you very much, Chuck.
Mhm.
We'll be able to double click on this in the live view here in just a little bit. A good station, a good RDS is going to look exactly like what you see here in the display in front of
Clearly
us.
defined white spots. Yep.
Exactly. The pilot, the 19 kilohertz pilot, and the 57 kilohertz RDS deviation are shown right below that. And then to the
I should
right,
mention here that
yeah,
those are
yeah, yeah,
expressed in kilohertz, not in percentage, which is
that's
what we
correct.
typically think about. So this 7.2%
Hmm.
or kilohertz is actually somewhere around a 9% pilot injection level.
Right, because in the past when we were dealing with pilot, we'd always say, "Oh, we have 10% injection, or 9 or 8."
Yep.
So this is, yeah, it is a deviation there.
So if you
Um,
want the percentage, you take that 7.269 divided by 75, and then you've
yep,
got the percentage. Okay.
exactly. The little screen or the little area right next to it, you see AF data. Now the
Hmm.
AF is actually alternate frequencies, and this is used to This is to identify translator frequencies when you are using a synchronous transmitters to fill the holes in your signal, and this allows the receiver to switch to the full transit or the fill transmitter if that signal is stronger.
Yep.
To the right of that, there's your LED display with the left, right, L plus R, L minus R, your 19 kilohertz, and then your RDS, all viewable right there in front of you. Just as a glance, it's a really good indication to look at first.
Great. Okay. And we should say that this, when it says 0 dB here, what it's saying is 75 kilohertz deviation.
That's correct. That is correct.
So it's all related to 75 kilohertz deviation.
That's right.
Okay. So here's
Let's
the
go back.
RF spectrum analyzer, the first of 3 kinds of spectrum analyzers this machine has.
Right. And if this is kind of the side view of what we were looking at. We are looking here at on the very left-hand side over here. We're looking at the vertical axis, which is all configurable, and it's showing right now minus 72 dBm to 132 dBm.
Mm-hmm.
In the middle here are your 2 HD sidebands with your center, your analog carrier here at 106.7.
Mm-hmm.
The horizontal axis, it's all configurable. We are showing from the far left at 106.1 all the way out to 107.3.
Mm-hmm.
Now the red arrows on the sign with the red, white, and the blue, we are looking at high, average, and then the lowest.
Think of it as the peak level that's at that frequency and the lowest level that's been seen. Now, one thing that's very important, this picture was taken with an off the air, bunch of miles away from the transmitter signal. So there's multipath and other things happening. So this is not actually representative of what's actually coming out of the transmitter. It is going to be susceptible to multipath and other signals, interference, noise, and so it is not representative. If we actually hooked this up to the back of the transmitter, you'd see a much more well-defined
Absolutely.
Display.
Absolutely. And it's as Chuck said, it is a good representation of what you are of what you're seeing. Let's go ahead and go to this next one here, Chuck.
Okay, so one of the things that's really interesting in the US is actually looking at the overmodulation limits for FM. And it basically, in part 73.1570 in the FCC rules, it says that the total modulation must not exceed 100% on frequent reoccurrence reference to 75 kilohertz deviation. However, you can get a little bit more for each percent of subcarrier injection modulation. But in no event can it go beyond 110% or 82.5 kilohertz peak deviation. And it's interesting that in the United States these days, you don't have to have a modulation monitor, but you're responsible for assuring that you meet those FCC requirements, including modulation levels. So checking the modulation on your stations with an avatar could help save you from a hefty fine. So it's kind of like, if you're driving a car with no speedometer, well, that's probably okay, but that doesn't get you out of a ticket if you're going too fast.
That's right. You are self-policing yourself.
Absolutely. So let's talk about deviation. Since deviation is really the key, let's look at how the avatar analyzes deviation.
Yeah, this is interesting. That we are now in the center section of the visual here in Avatar. Deviation on the left. We're looking now at the vertical axis deviation from minus 100 to plus 100 kilohertz. The fixed division is 50 microseconds per division. And then the dotted lines, as we can see on the right-hand side, these are your upper and lower peak deviations.
Mm-hmm.
The LED display to the right will correspond to the peaks and the of the meter to the left.
Right.
Center is a deviation history. Now this is one that we can actually go and adjust as needed. When we double click on this here in just a little bit, you'll see that we'll be able to go from 1 second to 15 seconds to a minute to an hour, depending on what you want to see as your deviation history to display.
Sure.
And then the deviation, of course, is shown up here at the top. The histogram is basically just history.
Well, it's actually a statistical analysis
Right.
of your modulation, seeing how well your modulation is controlled. So you can see not only the average level, the mean deviation, but also the variation to that, and then calculating the standard deviation all simultaneously. So it's telling you what kind of job your audio processor is
Mhm.
doing in terms of controlling your modulation.
And that is shown right there at the very bottom of the screen with the
Mhm.
numerical MV and SD down there.
Right.
Okay.
Okay, this is the second of the spectrum analyzers in
I
here, but
love
this
this
one's
thing.
multiplex spectrum.
Yeah, that's right. And this is one of my favorites because I like to see what's going on out there. Uh, Looking at 0 to minus 100 dBm, let's just look across here. We're looking all the way from DC to 100 kilohertz here. We have your 0 to 15 kilohertz left plus right, and your L minus right information right here. Right next to this, here's your 19 kilohertz pilot. A little bit further over, here's your 38 kilohertz double sideband suppressed uh,
Carrier.
carrier. Thank you. I was going to say band for some reason. And then your
Hmm.
L minus R information. Your 57 kilohertz subcarrier RDS is over here next to it. When I was driving back to San Antonio here this last weekend, I took this with me and stopped at several little towns along the way trying to do a screen grab of somebody using a 67 or 92. And I did find one at 67, but by the time I tried to grab the screen, it was gone. And I figured it was just a remote control system that was being used in one of the small communities out there. So it's kind of fun. Set this up on top of your car, look and see what's going on in other areas as you drive around too.
You bet. Okay, let's see here. See if I can change the screen. There we go. This one's kind of cool. This is, a relative indication of loudness, of
Right.
perceived loudness.
That's right. Perceived loudness. And at the bottom, we have a numerical value, and then we have a graph at the top. And the average power over the time measured is down here at the bottom. And in general, the higher the number, the more dense or the louder that it's going to be. And as you can see right next to it, you can see what the time that was measured during the to get this average. So 8.94 over 37 minutes and 12 seconds. And it just continually goes on. You can run this forever if you want to. And the line right above it is referencing is equating to the average power of 8.94, which is shown below to the left.
Probably useful to dispel any misunderstanding here. When we're talking about power, we're not talking about RF power or even the power in sidebands, which is difficult to measure. We're talking about the amount of power in the modulation. If you were to do an RMS calculation of the
Mhm.
voltage coming out of a radio, and you would end up with a number in power, and that's what this is, and it's a relative indication of the loudness.
Yes.
Okay,
All right.
cool. And
Move
now
on.
the third of the three spectrum analyzers, there's the audio spectrum analyzer.
This is fun to look at. As we look at this, we have a lot of stuff that is going on. We have our audio. Let me just start at the very bottom of this time because uh, there's a lot of things that you can when you pop open the screen, you can select so many items here. Right now, we're looking at the L plus R audio. I can deselect that if I want to, and then go pull L minus R, or I can look at the left only or the right only. I can pull the averaging out and the maximum and minimum. There's so many things that I can actually take a look at. And what we're looking at is audio that is measured from 0 to 16 kilohertz across the screen here. The red is the maximum hold of the peak audio. The
Hmm.
green is your L plus R audio, as I have selected over here in the bottom. The white is the average audio, and the blue is your minimum hold audio. And as I
Okay,
said, we can pull this out and we can adjust as needed.
let's look at this when we go to the live version.
Yes.
And then we have a stereo dual trace scope.
Yeah, and it's pretty self-explanatory, left and right audio, and then we have the time that measurement per division.
Yep. Okay. And then the Lissajou
Listens
stereo
you,
analysis.
listens you. That's a fun word.
Hmm.
Basically, it's your XY. It's your XY
Yep.
scope in a new form. We have left and right view on the left-hand side. There's your I guess, Chuck, would you call that a dot lists you as XY?
It's just it's a quarterless view because
Okay.
it's not all four quadrants. It's the upper right hand
Okay.
quadrant. But you think about it, it's the right channel
Mm-hmm.
is on the horizontal of the
Mm-hmm.
scope, and the left channel is in the vertical. And
Right.
what's interesting is if I look over here on the right hand display,
Mm-hmm.
there it's a straight line. That's
Right.
a mono voice, for instance, and you can
Right.
tell it is because there is no L minus R, which would be this way.
Right.
The L plus R is this way. If there was a bend here, for instance, there might have been some distortion in one channel only.
Mm-hmm.
If you're out of phase, this thing goes this way instead.
That's
And then
right.
over here, this is what stereo information looks like. And the red is the extents of the left and right audio over that period of time.
And that can be deselected if you didn't want to take a look at. As you can see over on the right hand side where mono, I've removed the red maximum hold indication. So
Mm-hmm.
it's all pre selectable.
Mm-hmm. Configurable. All right,
Configure.
so now let's go to the fun part. I'm going to give you control, John, and
Okay.
let's look at your device live.
Okay. You can see this, I guess, now.
Not yet, but I think I will in a
Oh, hang
second.
on a second. Let me hit that. I'll show my screen. Hopefully that does it now.
There we go. I
There
can
we
see
are.
it now.
Yay. Okay. So here we are. And this is the live version of this. And what we were talking about with the waterfall and the RDS information. And here I'll over here with the RDS is shown with it. Let's just pop this open. I can double click on just on any of these screens with the exception of the waterfall and pull information out. I can
Mm-hmm.
go over here to the RF spectrum. We can pull this over and look and see what's going on here on this station.
And the adjacent stations,
And the adjacent space
interestingly
because they were
enough.
getting up into a congested area of the band here in the Dallas Fort Worth area. There's your sidebands. Let's see, it looks like something down about 105.7, something else over at about 106.5 and
Something
106.
else over around 1067
Yep,
too.
yep. So I can pull off these minimum and maximum holds just to clean it up somewhat. I can do a trace over, which makes it kind of busy.
Yep.
And you may want it, you may not want it. I can change some of the resolution in here by using this information at the bottom. I could even actually copy it as well too.
Mm-hmm.
Here's a deviation we were looking at earlier. I can do the same type of trace over that was done earlier. I can remove all this type uh, uh, of other things if you needed to take a look at. Let's see, I'll get
Sure.
out of that right quick. There's your deviation history. This is one that I can actually change. If you see down here in the bottom right, I'm doing a 1 second per division sample. I can now change that to where it's a 1 minute. I can go to 15 minutes, 30 minutes. I can go up to 1 hour. I like to have the 1 second for a little more immediate look.
Sure.
Uh, and then back, let me pull this out of the way over here. Here's the deviation histogram that Chuck was explaining a little bit earlier.
Yep.
Okay. Then down here, here's your multiplex spectrum where we are looking. There's your 19 kilohertz pilot. There is a 57 right in there. There's a 38. I can
Mm-hmm.
trace. I can do trace overs. I can do. A lot of changing up in here. Also, don't forget we do have our presets. We can go look at other stations in the market. We'll see what's
Sure.
going on. I don't know. Let's see. There we go. So there's a classical station in the market. There's a classic rock. There's a country station. There is another CHR station. That is a college station right there. So you can look at pretty much everything that you need to do on your just at a glance.
Yep.
Modulation power, we look back down here, what we had looked at. This takes a little while for it to do because it has to do it over a specific period of time. So since I've just selected this station, it's going to take a little bit of time before that will fill in.
Yeah.
Here's your audio spectrum. I can take out all the maximum and minimum holds on this, the averaging, and just show your L plus R. Take that off. Here's your L minus R. Look at your left channel only or your right channel only. Everything is selectable just by a little click of the button.
Great.
There's our stereo. And then here's our stereo quality. This is you.
Yep.
And somebody is talking right now,
Yep.
for the most part. All right, Chuck, I'll let you take that back, sir.
All righty. Let me do that. And
I'll get out of
change
that.
to here. And we should be back on the screen.
Yeah.
All right.
There
So,
we go. So there's the live. Okay.
so
And
this is kind of an interesting thing. I mean, you can take this once you've got a computer and you can route the HDMI or VGA
yep.
or whatever you got to screens all over the station if you want to, and this could go out in the lobby or it could go in the on-the-air studio. People like to have kind of the Starship Enterprise in the on-the-air studio, don't they?
Yeah. Yeah, and I would if I was still engineering, I would want to have this in my office so I can just kind of look up at times and see what is going on. Or if I hear a glitch, I can easily look up and within a couple of seconds get an idea of what's happening. But
That's right.
all my presets are right there. It's just very easy to do.
So, in terms of how things connect to each other, the receiver that we've seen that you
Hmm.
showed
Yep.
is actually physically small, and it's connected up with USB to a
Right.
computer. The
Correct.
computer is where all the fancy processing gets done, and it
Correct.
would be the output of that computer. For instance,
Hmm.
you could use GoTo, or you could use what am I thinking about?
Oh,
VNC or
yeah.
or something like that to watch it from anywhere. So you could have this little box out at your transmitter site connected up to that lovely port on the back of
Hmm.
the transmitter,
Hmm.
and with excellent then performance, and then route that back as an IP signal back to PCs or whatever in your station, and be able to see an awful lot of information from wherever you are.
Exactly, and if you think about it, you could also set up some of these if you have stations in other markets that you need to want to monitor as well. You could do the exact same thing there and be able to access it and look
Well,
at
if
it.
you got a little notebook and you got
Yep,
your toolkit, you can throw this in your toolkit, and you've got an awful lot of test equipment in that toolkit.
absolutely you do. Absolutely you do.
Okay.
It's great to be able to take a look at. So in summary, uh, Avatar, just small, as you saw, it's only about 4.5 inches wide. It's a compact SDR test set, and you can take this everywhere. I throw it in my suitcase when I go with it, and I also, if I'm out, I just buy one of these little $6 collapsible antennas from Amazon to carry along with me, and that's great to have. You can monitor it from your office. You can take it to your transmitter site, connect it to the sample port. You can monitor up to 10 FM stations in your market. And there's full spectrum analysis of your signal as well as others in your market, covering everything from your audio separation to HD mask to RDS information and much more. One thing I do want to point out is that we're monitoring the HD mask, but we cannot demod the audio.
Correct.
We're just looking at information is what we're looking at here.
At
And
this
of course,
point.
16-bit accuracy.
Right.
Yeah.
Which
Yeah.
is really very good, honestly.
Absolutely.
16-bit accuracy is wonderful. All right, so let's continue on here. So,
Special. We do have a special going on. This is a list price of $2,500, but a limited time webinar special, $14.99 with free delivery within the U.S. And in July,
starting in
this will be
July 2020.
that's correct. This will be included free of charge, not including shipping, with any 5 kilowatt or higher Elenos or BEFM transmitter purchase. See your BE sales representative for details. Next slide. There we are. So, depending on where you are in the country, I handle the western part of the U.S. Joe Myers is in the middle of the U.S. He also handles all of Canada. Frank Grunstein handles all of the East Coast. Uh, we're easy to get hold of. These are direct numbers for us. If you are in the Latin America market, Daniel, Ernesto, and Ricardo, their information is in the bottom right-hand corner. So there are their phone numbers and their email addresses to contact them as needed.
I have noticed that we've gotten several questions here. Let's see if we can answer these, John. I will
Okay.
read them off to you.
Okay.
Okay, so let's see here. Expanding this.
And if
Okay.
I can't answer it, Chuck can answer it. And if he can't, then we're going to go to find somebody in the office that can do it, and we'll get back with you.
Friend of mine asks, is this webinar being recorded for future viewing? And absolutely we can.
Absolutely.
It is being recorded, and within the next year or so, the same website you use to sign up will have the video of this, as well as the PDF version of the slides there for you to take down, and it'll be on our, in addition, it'll be on our YouTube page. Approximate pricing and options, well, there's really no options to it at this point. And the pricing we just indicated. Does it record the spectrum? No, not at this point in time. This is an instantaneous test equipment. It does not do that. More indications of the RDS applications. There's a question. I'm not quite sure what that means. There's an awful lot of data here for RDS.
And I can get an answer. I can, if they'll leave their email address, I can answer them directly, get some more information, and answer that directly. By the way, there is one thing I did leave off on the avatar on the back. There are two ports on the back. There's a VHF, and then there's also an HF, which you can use to check on your 10.7 IF.
So it's interesting because the next question is does it have AM band monitoring? And the answer is yes and no. The device does cover the AM band, and you can see an RF spectrum of the AM band. In fact, everything between 100 kilohertz and 140 megahertz. Yeah. But it doesn't demodulate the AM band or do any of the sophisticated analysis. This is primarily an FM tool at this point in time. Yeah. And that brings up the next question. We've got a gentleman who has asked, how does this compare with the Looking Glass SDR? Looking Glass is a different style of product. It does work in the time domain. It does analyze the entire band at the same time and record things. Very powerful. Also a lot more expensive than this device, and not quite as portable as this. And do you have any idea of extending the promotion to the rest of the world, like South America, or better pricing for Canada, or for expending the free shipping? Talk to the regional sales manager in your area, and that's the best way to handle that.
Yeah, Daniel and Ricardo and Ernesto will be able to take care of that.
Sure. So that's the questions we've got. If you have more questions, you can go ahead and ask them, and we will answer them via email afterwards. We are very, very grateful that everybody had a chance to show up today. We know how valuable your time is, and we're honored that you chose to spend some time with us. Here's all of the email addresses of the people we've discussed, Mr. Lackness, for instance, and then you can also register for our schedule of upcoming free webinars. There's a whole bunch of really exciting, cool ones coming up as well. HTTPS www.elenosgroup.com/webinar. So, John, have you got any final thoughts you'd like to share with everybody?
You know, it's as we first started talking about the equipment that we have had in the past we take and how this has been miniaturized, it's amazing to see how things have progressed over the years. And now just having something that we can throw in, this is just an amazement to me that this can come in such a small package and be so powerful and get you the information that you need.
And so inexpensive.
Yes.
It's like half the price of what a mod monitor used to cost, and it's got 100 times the functions. Yep. I totally agree with you. The other thing that I would mention is that the old rule GIGO, garbage in, garbage out, applies. So if you have a noisy signal you're receiving off air 20 miles away from the FM station, the information you can see is going to be indicative of, in general, of the signal, but it's not going to be precision. You're going to have to provide it a high quality signal, like tapping the back of the transmitter, in order to get there. So GIGO still applies. Anything else, John?
That's it, man.
Thank you so much for all your help, John, and for John Lackness and the entire Elenos Group team. I'm Chuck Kelly, thanking you for being with us today. Bye-bye for now.